Okay, here's a demonstration of AdvancedSkeleton. First thing we'll do is bring in the geometry, and we'll do that by creating a reference. Because referencing makes it easier to allow for model changes to occur. First thing I'll do is I'll grab the top node of the model and put it on a display layer. I'm going to call this high, because it's going to be the high res version, and we'll have a low res version later too. Now, having it on a layer is quite handy. It allows me to template the geometry so I can easily see joints inside. Then we'll go ahead and bring in the biped fit skeleton template, and going to give it an appropriate placement right about there. Next, hip joint. So that's fine for the hip joint. Next is the knee. Now you should avoid moving around this joint because you'll lose the X down. You'll see if I select the joints in the channel box that we have a value of X only, meaning it's cleanly translated X down from its parent. If you were to move it, well, you'll get values in both. So instead of moving it around in all axes, just move it in X till you get the right distance from its parent. If you want it a bit more forward in your scene, instead of moving the joint itself, pick the parent and rotate it. Now the joint is ended up in the desired location, and if we select it, you'll see we have X, translate X only value, which is great. Same for the next joint. We do not wish to grab this ankle and move it into place. Instead, we're going to grab the knee, rotate the knee until it's pointing in the right direction. Then we'll grab the ankle and move it in translate X only until the lower leg is the right distance. We'll pop the heel in place. Same with the ball and toe joint over here. Alright, let's move on to the upper body. Spine. The spine seems to be doing fine already. The shoulder, however, needs to come out a bit further. And adjust it a bit from the top view here as well. Rotate the shoulder again. Elbow. Let's not move this into place, because you'll notice we don't have translate X only values here. I'll undo that and instead move translate X only till I have the right distance, and then apply some rotation to the parent joint to make sure it's in the right location. Again, don't move the wrist. Rotate the elbow to get the wrist into the right location. Next, we're going to look at the fingers. What I'm going to do now to help place the finger joint is create an additional orthographic camera that we are going to place nicely right in between the fingers, allowing us a clear cross-section view of the fingers as we place the joints. As we place the new orthographic camera near the first finger, notice how I'll rotate the camera to align with the orientation of the finger. And what we're also going to do is adjust the clipping planes to only see the first finger. So let's grab the joint, make sure the first joint is in the right place for the knuckle from the top view. And you'll notice this finger needs to be rotated down a bit. Now, beware, before you do that, take note that over here we have animation curves on these joints. These animation curves are, as a matter of fact, set-driven keys that are connected from this NURBS curve that lets you apply curl values. These curl values are set-driven key animated to these joints, which means it wouldn't do us no good to actually modify these values, as they are set-driven key animated. As soon as you change the curls again, they're just going to go ahead and pop back. So instead of rotating them, let's grab the curve editor. We'll just grab the entire curve and rotate it down till the finger is nicely aligned in the right direction. Next thing, grab the next joint down the chain, translate an X till you get the right distance. Again, translate X the next joint down till you get the right distance. If it's not in the right place, grab the parent and rotate it, or in this case with set-driven key animation on it, we'll just adjust the animation curve to get the right orientation. That's it, we got the first finger done. Now let's go from the top view. We can now see it actually needs a little bit of rotation in this Y-axis, but once again, beware, there is set-driven key animation here. So instead of rotating the joint, because that'll only pop it back, instead modify the set-driven key animation curve. There we go, that's nicely lined up, and that's the first finger done. Likewise, we're going to do the same for the other finger joints. Alright, so with the finger joints in position, all we got to do is the joints from the neck up, which is going to be neck joint, head joint, and eyes and jaw. Starting with the neck, we'll just place this at the base of the neck, and as per usual, do not just grab the head joint and move it, as you're going to lose your X down orientation. Translate X only till you get the desired length, but use the neck rotation to get the head joint moved forward. Then it might be a good idea to rotate the head back a bit again to get that world space orientation of the head. Next we'll do the eye joint, which we will line up firstly from a side view, right in the middle of the eyeball. Secondly, we're going to make sure it lines up from the front view as well. And the orientation of the eye, which in this case is going to be quite easy because the character is looking straight forward. Next is jaw joint, which we'll leave about here. Rotate it up a little bit. And that's it. We have successfully placed the fit skeleton joints. Every joint is now in their location. Next, we're going to build the advanced skeleton, which is done by simply selecting the top joint and press the advanced button. And there we go. We have a complete advanced skeleton motion system built for our character. It does not actually deform yet, but we'll get to that in the next video.